the audio. We're here with Chris Haupt, and Chris and I connected about 2 weeks ago through Telegram, through Uncom. Great dude, has a lot of experience in AI, much like Andrew from earlier, speaking on what AI has gone through. Andrew is going to be talking about the history of AI, and I have a feeling he's going to bring a lot of great energy, and I'm excited to hear what you're about to say. Thanks for joining us, Chris.
Thanks, Max. Yeah, it's funny because we did talk, and I know I was a little reluctant because I got a lot of stuff going on. So I kind of fall into the same camp as you, not getting a lot of sleep the last couple nights, getting this ready. So, but it was fun. I really enjoyed it and looking forward to sharing some stuff. This is not as practical as a lot of the talks are that you're probably going to see in the next few days and what Alan's talk was. But I think it is interesting just to kind of see where AI came from. And I'll also talk a little bit about what I think, where we're going, just at a high level. So let me share my presentation. Oh, I should get this in. Oh, helps to be here. There we go. Everybody seeing the screen okay?
Yeah, it looks good.
Okay, cool. All right. Well, thanks, Max, again for inviting me. And thank you all for joining today. I hope it's not just Max left at the end. And Max, if you leave, I'll really be upset. But since it is late for a lot of you, I had to clearly leave a lot of key moments in AI out from this, but I tried to pick a sampling of interesting things just to kind of, give you a taste of what's happened over the years. And so yeah, so my hat tip to Stephen Hawking. This is a brief history of AI. Just a tiny bit about me. I've always been fascinated with the brain and with human psychology. When I grew up, everybody said, "What do you want to be?" And I said, "A marine biologist or something with the brain." And I didn't know what a marine biologist was, but it sounded cool being at the beach. I got a degree in math and physics from University of San Diego, which is not really a bastion of science. And so a lot of my classes, I was the only person in it, which was not recommended for anybody. When I graduated, I joined the AI group at Naval Ocean Systems Center, which is the U.S. Navy's R&D lab based in San Diego. And then I got a chance to visit Carnegie Mellon University in 1985, working on some expert systems. Got a master's in computer science at UCSD in 1990 and did my master's project on training neural networks to recognize nursery songs for kids, which was, again, not very practical, but it was fun and interesting. Left the Navy in 95, started my own company, Online Sports, and now I own an Amazon marketing agency, helping brands thrive on Amazon. And I love being part of Uncom. I love interacting with folks like you, and I loved meeting Max last week. And my goals for Uncom are to get ripped and dunk again by the age of 65, which is a couple years away. So I got to get moving on that. Let's see. Here we go. So a brief history of AI. We'll talk a tiny bit about where it started. Just people have been enthralled by the idea of AI forever. And so we'll talk a little bit about that. There was the idea of automatons, which are devices that kind of mimic human behavior in some way. We'll talk about computers and kind of what they brought to the table, because obviously you need computers to do a lot of this stuff. We'll talk about the birth of AI in the 50s, the golden years, and then there were a couple AI winters that happened where funding kind of dried up and then it picked up again, and then kind of talk about where we are now. So AI in antiquity, let me move. I got you guys blocking my screen here. Let's move this here, because I like being able to see you all while I'm doing it. So yeah, there's a lot of examples of AI related ideas throughout the years. Why isn't this? I think I'm going to have to move you back where you were. Let's try this. Sorry about that. There we go. All right. So one example is this guy called Talos. He was a Greek myth that spoke of him. He was a giant bronze man who guarded the island of Crete by throwing stones at pirate ships. He is often seen as one of the earliest notions of a robot or a mechanical man. And then we have the golem, which is from Jewish folklore, a creature that is animated from inanimate matter. So it just, again, reflects the human aspiration to create and animate life. Of course, everybody knows Frankenstein by Mary Shelley, published in 1818. It tells the story of Dr. Frankenstein, who created this creature as a scientific experiment. It taps into the idea of man creating life and intelligence and the unintended consequences that can arise. And I think that's kind of a precursor of some of the concerns that have been expressed over the last couple of years over how fast things are moving, because they're moving real fast right now. So, and just a side note, that's what I want my arms to look like. I'm not quite there yet, but I'm working on it. There was a play by a Czech man named Karel Čapek that was called RUR, Rossum's Universal Robots, and that was the first mention of robots in any context, and so that was from 1920. Then through the years, there were these notions of automatons. The correct way to say it was automata or automata, but I don't like saying that, so I'm just going to put the plural on it my own way. So automatons, uh, they've come from many different civilizations. They didn't have advanced technology, and of course, and for programmability, but they were early examples of machines that could perform specific tasks. So here's one which is pretty cool from the 1200s. It's amazing. I was showing my wife this, and she's like, "How did they do that back in 1200s?" But Al-Jazari was a guy who created a water-powered automaton orchestra that would float on a lake and provide music during parties. It included a four-piece band, a harpist, and a couple other players, accompanied by a crew of oarsmen who rowed the musicians around the lake. And then there were different drums you could put on it so that it could produce different sounds, and allowed the musicians and crewmen to make sort of realistic movements. So the pegs on the drums is kind of like the first programmable computer. So that's kind of an interesting point in time. And then, of course, Leonardo da Vinci, he's kind of the Elon Musk of his time, just kind of delving into everything he can get his hands on. And he made what's called Da Vinci's Knight, which was a mechanical creation that imitates basic human movements, showing once again the fascination of creating man-made objects that simulate living organisms. And then it brings us quickly into the 1900s. The seeds of AI were planted by classical philosophers way back when. Because they talked about the process of human thinking as mechanical manipulation of symbols. And this insight finally culminated in the invention of the programmable computer back in the 1940s. So a computer is basically a machine bringing to physical reality the abstract essence of a mathematical reasoning. And this obviously was important and needed to be able to discuss the possibility of building an electronic brain. So the device you're seeing here was called the ENIAC, which was developed at the University of Pennsylvania and is often credited as the first general purpose electronic digital computer. And then Alan Turing also created a device about the same time called Colossus. Alan Turing's another amazing man who delved in a lot of areas. He's considered the father of computer science because he introduced the notion of the Turing machine in 1936. which is another theoretical idea that serves as the foundation for understanding how you can turn this into a computer, an actual electronic computer. And he was also pivotal. If you've never seen The Imitation Game, which is a show about Alan Turing, a movie, I highly recommend it. Very interesting. That explains his role in cracking the Enigma code during World War II and showcase the practical applications of computer science. Because I don't know that everybody believed in it, but this showed how quickly you can develop things to crack an amazing crypto process that the Germans had developed. And not to be outdone, he's also considered one of the fathers of artificial intelligence because he introduced the idea of a Turing test. That's called the Turing test now. And it kind of anticipates the Chat GPT phenomenon we're experiencing now. So the Turing test, I don't know if have any of you heard about that? If you want to just give them a hand raise. It's an interesting idea. It's based on his what he called the imitation game, and it's his proposed method for assessing whether a machine has human intelligence. So the way it works is at the bottom, you're the judge. You're sitting at this bottom computer, and you're talking by text with two other computers. You can ask them questions. You get answers back. And then at the end of the process, you have to decide which of those two. So one of the computers is from a human, and the other one is from some sort of AI. And at the end of the session, you as the judge have to decide which one was human and which one was AI. And if you don't hit a certain rate on that, then you basically the AI has proven that it has human intelligence. There's kind of a percentage that goes with it. But anyway, it's kind of an interesting idea. And the only flaw is that there have been some flaws pointed out, meaning that, someone can invoke their Fifth Amendment right not to answer and just not respond. And that would be perfectly human thing to do that might not prove their non-humanness. Or, computers would have to realize, okay, if I'm going to look like a human, I need to throw in spelling errors and inconsistent arguments and all kinds of crazy stuff to try to fool the judge. So here's another example where, okay, so this robot arms says, I got to be cute and throw in my LOL and smiley face to make this work. Golden years, 1956 to 74. Which came soon after the Turing test. There was John McCarthy from MIT, or actually from Dartmouth, created a conference called the AI conference. He coined the term AI back in 56. And a couple of the folks that were there were Alan Newell. Let me turn on this real quick, just a second. Yeah, so Alan Newell and Herb Simon, they were both from Carnegie Mellon University. And I actually got a chance to meet Alan Newell when I was at Carnegie Mellon for a year back in 1985. And he was really nice man, quiet. And I didn't really know him. I was just in on a couple meetings, but I just remember him standing through all the meetings because he had a bad back. So that was my recollection of him. But what they came up with, actually, I'll get to that in a minute. So John McCarthy is considered the father of AI. I guess there's an old expression: success has many fathers, but failure is an orphan. So AI has many fathers, and John McCarthy is probably one of the key fathers of it. He was an American computer scientist. He coined the term artificial intelligence in 1955. He played a pivotal role of making it a legitimate field of study, because I think a lot of people just thought of it as a toy area to study. And he developed a programming language called Lisp, which stands for List Processor. And that was a foundational tool in AI development through the years. I don't know how much it's used now, but it was very foundational in the early years. Here's Herb Simon and Alan Newell. They developed a device called the General Problem Solver, which was an early attempt to create a universal problem-solving method. So it would repeatedly apply heuristics, which are kind of rules of thumb, things that an expert might know. and then performed an analysis to see whether these rules help you get closer to your solution or further away. And again, these were all crude early attempts, and these aren't in use anymore, but it just helps pave the way for future developments. Here's an interesting one that came out. I don't remember what year that. Do I have it in there? Yeah, I don't remember when this was. It was probably in the 50s or 60s. Joseph Weizenbaum from MIT developed an early chatbot-like item, which was called ELIZA, which could emulate a psychotherapist in the Carl Rogers school. So here's an example conversation. So the human says, well, my boyfriend made me come here. And Eliza says, your boyfriend made you come here? And the human says, he says I'm depressed much of the time. Eliza, I'm sorry to hear you are depressed. Human, it's true, I'm unhappy. Eliza, do you think coming here will help you not be unhappy? So, us looking at it from our chatbot point of view, that looks pretty primitive. And, but there was a lot that went into that. There was pattern recognition. They had to be able to recognize what topic they were talking about. And then they had a series of ways, like a therapist would do, to kind of push the conversation along. And what, interestingly enough, is people became very attached to Eliza. It's kind of like the movie Her. I don't know if you've all seen the movie Her, which was also, I mean, that's much more human-like, but this effect of becoming attached to a computer program which is producing answers became to be known as the Eliza effect. And a famous story is when Weizenbaum was watching his secretary use the software, and she was aware that it was a simulation. She asked Weizenbaum to leave the room so that she and Eliza could have a real conversation. So she felt attached to it, and even though she knew it wasn't real. And I don't know how you all feel using ChatGPT, but I feel that effect using ChatGPT. I feel like I'm really, in a lot of ways, talking to a person on the other side, a smart, helpful, patient person who's willing to answer my questions and is very adept at understanding what I'm asking. I've stopped using exclamation points or question marks, because I know they don't need it. So anyway, this was like an early chatbot idea. Then we hit an AI winter during the 70s up until 1980. There's some reports that came out that criticized AI, saying it wasn't making much progress and it wasn't worth the money. So both in the UK and the US, funding dropped significantly. And fundamental challenges kind of became obvious. Early AI researchers discovered that tasks they thought were simple, like general visual perception, were incredibly complex. But they also found that some things that they thought would be difficult, like playing chess at a high level, were more tractable than they thought. So again, what we'll see over and over again, even though funding was reduced, there's still lots of great research that was going on during these so-called winters that eventually led to big breakthroughs in subsequent years. Then in 1980 through 1987, kind of became another boom in AI research. One of the booming areas was called expert systems. And they're called that because you're basically trying to catalog into a set of rules all the things that an expert in that domain understands and uses. So you can see here, we've got a human expert who's talking to what's called a knowledge engineer, a knowledge engineer is trained on trying to pull information and rules out of a human expert. And then he puts that into a knowledge base, which you can think of as a lot of if-then rules, like if you see this or that, then this is the conclusion you draw. And then the inference engine kind of drives all this stuff. And then an answer comes out to the user on the other end who may not be an expert. So I got to witness expert systems being built firsthand when I was at Carnegie Mellon, because that was really the boom year. And I was there in 1985 and worked with a lot of folks who were working on making rules-based systems work more efficiently, because they were kind of slow. They were just, they had to work in serial. There was no parallel processing. So it was something that just didn't work very well at the time. Over time, it became clear that there were some problems, and we'll talk about those. But one example that one of the types of things that I was working on, so you have a plane that is positioned relative to you're on a Navy ship and you have an airplane nearby. And we want some things we want to know are, is the plane friendly? Is it moving towards us or away from us? And an inference engine would run that a particular rule like that and say, if the plane is not known, we don't know if it's friendly or not, or maybe we know that it's not friendly and is close to the ship and approaching, then raise an alarm. And then the user can decide on the best course of action after that. So that's kind of a simple way to think of what an expert system does. That's one rule, and then there's going to be hundreds or thousands of rules that are all firing off, trying to make sense of the data coming in. There were a lot of expert systems that ended up being made that were useful. I mean, there was some in the world of medicine, like Mycin, which identified bacteria, and Caduceus, which helped doctors diagnose tough cases. And then in chemistry, there was Dendril, which was helpful in mass spectrometry. And then geology had Prospector. XCon was created by DEC, the computer company, to help configure computer systems. And then NASA even had one called Pioneer, which helped them plan space missions. So AI expert systems were not complete failures. They just had some problems and flaws. And the big problems were the knowledge acquisition bottleneck, because you have to get this information out of a domain expert into the AI system. And domain experts don't always even know how they do the things that they do. They may not know what it is that, what kind of rules they're following, or maybe there's just so many rules that they don't, there's so many special cases. And that's another one, that under brittleness, there's so many cases that you have to account for that rules just don't work very well for. It's not able to learn on its own because it's only as good as the rules you've put in. And it relies heavily on formal logic, which sometimes can fail because heuristic-based reasoning that humans use in complex real-world situations, again, it's just very nuanced, and expert systems aren't able to capture that. So what came to the rescue was the artificial neural networks. So there's a few things about artificial neural networks which make them really powerful, and I'll talk about how they work in a minute, but this is kind of the basis of a lot of the stuff that's happened over the last 30 years, and especially the last few years. So it is interesting to kind of understand how this works. So they have the ability to generalize from examples. So this means they can make reasonable decisions on data they've never seen before. So you've trained it up on some data, but then it sees new stuff, and it's learned from the data that you gave it before how to handle the new stuff that it's never seen before, which, as we saw with expert systems, that doesn't work. So they're adaptive. They can learn and adapt to the new information, and they have noise tolerance. So the data doesn't have to be perfect. During the training, actually a little noise is helpful so that it doesn't get too trained up on any one particular piece of training material. Because of their nature of networks, they can leverage modern GPU architecture, which allows parallel processing, so they can be running lots of different steps along the way. And that is in contrast to expert systems, which follow a sequential rule checking system. When I was at CMU, there was a guy there named Lanny Forgey who was trying to make rule-based systems a little more parallel, but it was not an easy task. They're versatile across domains. Even if you have a neural network for one area, they can often be applied to other domains. And it's worth noting that while neural networks have addressed many of the limitations of expert systems, they've introduced some of their own challenges. And one of them is interpretability of the answers, meaning it's kind of like a black box. It's hard to know why it made the decisions it did from the very nature of it. And that is something that people are working on, because it would be helpful to know at times, well, why is this decision the decision that you made? So I can see if it makes sense for me. So to understand how artificial neural networks work, let's talk briefly about how human neural networks work. So here's a simplified representation. You've got some input that comes into the person. Their brain is full of these basic connections called neurons. And your brain has billions of these neurons interconnected by wires and wires called dendrites and axons, and synapses between the neurons, which kind of a neuron firing means it activated the neuron that's next to it in the chain. And so you've got all these highly connected things going on. It's has layered processing because different areas of the brain are responsible for different processing. So the visual cortex is an area that's set up to handle vision tasks, and then you have the auditory cortex for sound, and then so you go through this processing, and at the end you get some kind of answer saying it's a cat. And we all know kids that when kids are learning, they make mistakes, and that's just what the way a neural network does. Is you start training it on things, it makes mistakes, and it starts learning what works and what's right and what's not, and adjusting accordingly. So here's kind of the translation of the human neural network into an artificial neural network. So on the left, you have some input. So this is representing some MRI images of a human's brain. You can't just pass that in directly. You have to break it up into some sort of data that is structured and standardized. So this gets chopped up and then put into a big array of all these little pieces from it. You can see like this piece came from here, this piece came from here. And then there's all these connections with these what are called nodes. So these are kind of the equivalents of the neurons for the human. These nodes have weights on them. So when this little piece here fires off, it's touching this node. At this level, everything's touching all that first level node of the neural network. But then from there, these nodes talk to just some of the nodes here, and so on through the chain until you get to the end where you want to get an answer back. And so the answer here is you're trying to decide, was there an infarction with this brain? Was there hemorrhage? Or was it a tumor? And so if the answer was it was supposed to be a tumor, and the answer that came back said 25% chance it's a tumor, 10% it's a hemorrhage, and 0% it's an infarction. Well, it really should have said 90% chance, the high probability that that there's a tumor in there. So in this case, if it just says 25%, then that means this network has to be trained a little bit. So what happens is, working backwards from here, these weights get adjusted on this layer. And then this layer says, I need to adjust these weights. And then this layer adjusts these weights, and so on back to the front end. So you're making tiny little changes. You're training it on hundreds, thousands, millions of examples. And each time you're making tiny little changes so that when you actually get real data that you weren't trained on, that you're going to be more likely to get the right answer. So there's a lot of math that goes on in here, but it's basically trying to get these connections so that they recognize what's going on. Then we had a second AI winter, again, overhyped, funding reduced, lots of criticisms going on. And again, a lot of great work was going on during that time. So 1993 to 2011, this was a huge boom area. Part of it came from the advent of the internet and the digital ability to have massive data sets available for people who wanted to train the neural networks. Also, the computational power grew enough to allow some of the things that people were developing to be coded and ran in a reasonable time frame. And then there was a renaissance of the neural networks that had been developed a couple decades before. So Moore's law basically just says that every 2 years, the computing power is going to double. And so that kind of exponential growth was needed to be able to start handling some of the processing that was needed. And then from 2011 to present, I think we know one of these. The second one, GPT, currently is occupying a huge place in all of our psyches with what it's able to do. But there's a lot of other cool stuff going on. There was deep learning breakthroughs in what that is. Actually, I'll talk about deep learning in a minute in a tiny bit more detail. And there was this reinforcement learning, which was a method that allowed a company to create a system that actually was able to beat the Go champion. And Go is an extremely complicated game, and it showed its ability to create a complex decision-making program that can work at a high level. And then generative models, what we've seen, I had generated a bunch of the images here from Midjourney. I don't know if any of you have heard of, actually, if you can throw in the chat, if you've heard of Midjourney, it's called MID and then just the word journey. It's a really cool tool for generating images based on some prompts that you give it. And that kind of came out of some of the work that was done during this time. So deep learning, it's still based on neural networks from before, but it gets the word deep because it's using multiple layers to do the learning. So there's different levels of abstraction as opposed to just kind of one layer going through and touching the layers after it. And it's able to handle large data sets and be using powerful tasks such as image processing, speech recognition, natural language processing, and game playing. And one interesting aspect of it is it's end-to-end learning. So traditional machine learning, and especially expert systems, often requires manual feature extraction. So you have to have somebody who knows what to look for in the images. Whereas deep learning can actually learn what are the essential features directly from the data. So that means you're able to pull a human out of the human doesn't have to intervene into the process to make this work. So that's a really key step for this. And yes, as you would expect, this requires vast amounts of data and computation. And so again, the computational resources to do this have to keep growing in order to kind of stay on top of all this stuff. ChatGPT. So ChatGPT is talking to a program called GPT, which stands for Generative Pre-trained Transform. So generative means it can generate text. Pre-trained means it can take massive amounts of textual inputs. And then transform means it's basically the name of the specific technology that they used to create this. It's particularly effective at processing sequences of data, such as text. You're putting in sentences and paragraphs. And so it's a model that allows the system to be able to deal with that. So what's next? I mean, this is where we are now. We know ChatGPT is really taken hold. There's a few things going on. The development of, so what's next in terms of hardware is the development of faster, again, and smaller GPUs. Smaller so that chips can be able to be put in smaller devices, to power whatever. The smaller, the more things it can be touching. NVIDIA, the NVIDIA CEO has placed a $25 billion bet that AI is just starting. The bet being they're buying back $25 billion worth of their stock, which means they think their stock is highly undervalued. And they put a lot of effort into creating high capacity, fast GPUs a couple of years ago, and they really have gotten to the point where they almost have a monopoly on GPUs used for AI type applications. So a lot of companies are playing catch up. I mean, there's a lot of smart companies out there, Intel and Amazon and AMD and all the other chip manufacturers that are out there are trying to play catch up. Um, and what's next in terms of software? Um, there's development going on of an AI specific programming language. So that would mean it's called Mojo, and it's built on Python, which is it's the second most used language in the world right now after JavaScript. And I have an interesting story with Chat GPT to create code. And it was, a couple years ago, I had a script in a language called Perl, which could read an Excel file and pull out some time data that I had. That stopped working, and Perl just isn't quite as up to date as Python is. And I'd never used Python before. So I just asked Chat GPT, I handed it my Perl script and said, can you convert this to Python? And a minute later, I had my Python script. I tried it, it didn't work, but I got the errors. I fed the errors back to Chat GPT, and it would say, oh, sorry, please change this function to this new version. So I would plug in the new version, try again, get a new error. And I kind of iterated a few times with that until the script was working after about 15 minutes of work. And again, I'd never touched Python before. And that just blew me away. So I feel like code assistance, helping people, even novice programmers, people that haven't done a lot of programming, can really get into the code world fairly quickly. I'm not sure how this scales up to larger, complex systems, programs, but maybe Chat GPT can also analyze the complex system and be able to help a developer say, how does this work? Where should I be looking to find this? So I really think it's going to have a huge impact on programming and programmers. And as I finished, I have to say that since I did all the work I did in AI just 35 years ago, so it's been a long time, and I've had my own AI winter since then. I haven't done much, but I'm very interested in getting back into it and learning and staying up to speed, both for my own business and just because it's such a cool, fascinating area. So any of you that are interested, I'd be happy to chat more with you in this area, or if you're doing anything, or even if you're not doing anything, I love talking about it. Neural networks are really cool stuff, and all the things that they've allowed to have happen. And this image, since I can't dunk a basketball yet, I'll end on this slide with this picture of Alan Turing rising up to dunk a basketball over his detractors. So that's where I'll be in a couple of years, hopefully. And I'll just say thanks for your interest in AI, and thanks for staying on through this talk that really has no practical applications, but I appreciate you guys hanging in there.
Yeah, maybe no practical applications aside from the coding, but
Yeah.
as you're going through, it just seems so relevant to understand the history of something like this if we're going to be utilizing it. Like, even I had a question, like, do you think that the AI itself knows its history, or is it like, I don't know how to frame that question, but like, if I'm talking to ChatGPT, does it know that it's developed through all this, or is it
Yeah.
totally blind to that?
No, I think if you could probably ask it that question, and it could, I mean, to be honest, I use ChatGPT to help me create this presentation in a 2-day time frame. I didn't have a chance to really, if I was just doing it using Google, it would have taken a lot longer. I could ask it really basic questions and say, what were the key points of the AI winter? What happened during that time? So ChatGPT has got all this text in it, and it really seems to understand. When there's not many questions that I ask and it comes back with something that I'm like, well, that's not really what I was asking. So I feel like, I mean, when you say, does it know it? I mean, it knows it in the sense of it's got it in its textual basis and is able to talk about it intelligently. So from a Turing test point of view, I think the answer is yes, it definitely knows all of this history.
Yeah, it's
Yeah.
so fascinating. Does anybody else have questions?
Has anybody been using Chat GPT for, I know Alan's presentation, he had a lot of really interesting, cool applications of it. Has anybody else done some things that I'll use one example and then I'll open the question up. But another way I use this is my daughter was applying for some jobs. She's not happy where she's at, and she sent me her resume, or she sent me her cover letter that she was proposing to send to a job that had a specific, they had an application or a, what do you call it? An announcement of what they're looking for, what the requirements are, and all that. I gave ChatGPT her cover letter. I gave ChatGPT her the job posting, and I said, rewrite the cover letter so that it better addresses the points mentioned in the job posting. And what came back just knocked my socks off. I mean, I literally changed one word in her posting, and that was, it said something like, I am keen to learn. And that's keen, I think, is maybe more of a British term, and it's not something that a typical American would say. So I said, let's change that. But other than that, it was completely usable as was, because it didn't change everything that she had. It just sort of added nuance to things and then said, you didn't really address this point. I mean, it told us that. It said, you didn't address this point. Here's how I would address it. And it really made it into a beautiful cover letter just through a quick process of doing that. Yeah. So anything else that you guys are finding useful for it with ChatGPT, or with any other things like creating images or creating videos? We're starting for our business to explore video creation apps that are out there also, but we haven't gotten very far with that.
I've been noticing a lot of the AI art like everywhere. Like sometimes I'll use Pinterest, and it seems like I almost can't see anything other than AI art. And I'm like
Mm-hmm.
starting to pick up what it is because the hands are kind of messed up, and then
Mm-hmm.
there's like a weird arm coming out of somewhere. Do you think that like probably pretty soon there'll be a lot more accurate models, at least for the human body, so there's not six fingers and three on the other? Is that probably fairly close?
Yeah. Yeah. No, I would think that they're just going to get better and better. I mean, my son was telling me that the new Barbie movie apparently used a new program that's out where you basically film what you're going to film, and then you can sort of identify the human in the film and turn them into a cartoon. I haven't seen the movie, so I don't know exactly what it looks like, but it's that would be another interesting way that the system could have a huge library of actual humans, that it was trained on. So I would guess that it would very quickly continue to get better at producing more realistic stuff. Because I think the video games that are out there that have been around for a few years, they're already doing a lot better at that. I mean, they typically use a library of humans that come in and they put, dots all over their body. So, and then they have them run and do things. So they've got this huge catalog of realistic movements and patterns. And so I don't see why this couldn't come from a system watching videos, or putting lots of videos of a person together until it can decide what it should look like from a 3D type of model. That's a great question, though.
I've got a question. I'm not sure if it would relate to AI, but maybe it does. I've heard that kind of like a digital computer broken down simply is just something that uses ones and zeros. Then an analog is something that uses more of a spectrum between a one and a zero, or just a spectrum in general, voltage, frequency. Do you think there's any potential for AI to go back to an
Hmm.
analog system? I don't know how like I'm also curious how is the human brain digital in the sense of zero ones and zeros with the neurons, or is it more analog, or is it something completely different?
My understanding it is more analog. So that's a really fascinating question. I mean, it seems like if you could connect up uh, things in an arbitrary way, and that's what's interesting is how the brain works. From when you're training, what you're doing when you're training is you're teaching these neurons to create to grow a myelin sheath around the axons that are talking to other neurons in the area. And so what this little sheath, which is kind of a little fatty layer, it's an insulator. So what it does is allows the transmission to happen faster when you've trained it up. So you're throwing a lot of, there's a great book called The Talent Code, if you're interested in this idea, where it talks about how people learn. So, I mean, I'm kind of getting off your question, but I think basically the idea that you brought up, which I think could make a lot of sense, is that in analog, if you could create a lot of little analog neurons and just throw them together and have them start connecting up, it seems like you could start, and then, a ton of training, because, when we're born, we start off with just a big blob in there that doesn't know much. So it takes, what does it take a year? I've got a 2-year-old granddaughter, and she's just now starting to make sense with her words. I mean, they make sense to her parents, but now I can understand her too, so there's a ton of training that has to go on there to convert that blob into patterns that make sense, and networks that can talk reasonably together. But yeah, no, it's an interesting thought. The other thing that's happening, there's this whole world of quantum computing, which I have done zero research on, so I don't know exactly what that looks like, but there's a lot of people working really hard on that as kind of a next generation thing that could really impact the speed. I don't think it answers your point of sort of the analog version, but yeah, I don't know if I answered your question, but that's a great question.
My only last thought with the neurons is I could see it almost working as binary or digital and analog, if because the neuron either fires or it doesn't fire, but the strength of the connection could almost be viewed as an analog. Like maybe there's instances where it's not strong enough, where
Yeah.
sometimes it fires, sometimes it doesn't. Versus, yeah, I don't know.
Yeah, no, I think that's exactly right. I mean, if we go back to the node picture with all these interconnected dots that I showed, that's exactly what it is. It's the weight of the connections that decides whether something is going to fire it or not. Because there's a function at the node, the synapse, that says it's like a threshold that, it's like, just like you're saying, you have to cross this threshold before you fire. And if you don't cross it, it's not going to fire. So that connection is not going to happen. So there was something else I was going to say about that. What was it? Yeah, I don't know. It slipped away. But yeah, no, I know what I was going to say. And this again, and I think this is the point you were making. Like when you're firing a muscle, your muscle, a muscle fiber, a single muscle fiber will either fire completely or it will not fire. And so when you're so, but your bicep has a ton of muscle fibers. So some of them are firing completely and some are not firing at all. So that's why you can have smooth motion, because this group of muscles together can work in a smooth way. So I think, kind of coming back to your earlier point, is maybe it's these groups of neurons that can have a higher level function together, where one of them just is either on or not on, but as a group they have the more sophisticated behavior of firing in sort of these analog type of ways.
Another question, if that's okay. Would the breakthrough with quantum computing, would that be like a possible way to prevent a third AI winter? Because I feel like everyone's got like super excited about ChatGPT, and then one of our presenters earlier was showing like there's probably going to be a dip where like, it actually kind of sucks. You can't do X, Y, Z, and be my girlfriend or whatever. So would we need to like make some significant strides in tech so we can meet those expectations?
Well, I think yeah, no, that's a great question. I think we're always hungry for more, and so it's amazing where we are now. And it just means that people keep pushing, and it's like, so something we wouldn't have tried today or 5 years ago, because we just didn't have the processing power. All of a sudden, once the processors, double and then double again, now that training program that would have taken 5 years or 100 years drops to 30 days or whatever. So it's I don't, and again, I think this whole idea of an AI winter, I guess the point of an AI winter is that big government funding kind of dropped off. I don't think the interest dropped off from people that are interested in it. It's just the people that are handing out the money. That's where the interest dropped, because they weren't getting their bang for the buck that they want to make. And so I don't really see winters, except maybe from, I mean, it makes it hard for the researchers sometimes if they don't have the funding they need, but the good researchers stay at it anyway, because they're just, that's all they have to do it, you know? So I just think it's the classic thing about patience. You know, we do with what we have at the moment, while other smart people in the hardware world and the software world are making it easier to be able to do the things we want to do, so that in a year we can do something a little bit faster and a little bit easier, and be able to visualize it a little bit better. Yeah, but to answer your real specific question about quantum computers, I don't know if quantum computers means we would have a quantum leap in processing speed. And again, I just know zero about it. I haven't even put it into Chat GPT. I will be doing that this weekend, obviously, because I think it's an interesting question, is what is the promise of a quantum computer? How is it supposed to even work? I mean, I think the idea is it's this idea of multiple universes that are implied in a quantum world. And somehow you can get answers from multiple universes. I don't know, I might be making that up. Maybe that's a science fiction book I need to write, but that's kind of what I thought I had read at some point, and that's where you're going to get these huge improvements in speed. So yeah, we'll have to get back together at some point and see what we find out. It'd be fun to get back together in a year and say, where are we now compared to where we were this time at this point?
I've got a quick question. It's a little left of field. But you seem to, first of all, thank you for all the information you've shared. It's been great. You seem to have a really good understanding of the history of AI, as well as the progression and where it's going, as well as you sort of seem to also have a really good understanding of just how the brain functions itself.
Mm-hmm.
What do you think of the likelihood of like a sort of AI-powered Neurolink-esque thing in the near future? Like, what are your thoughts on that?
I think it's here already. I just heard on the news this morning of a woman who, I forget what happened. I think she had a stroke or something, and it affected her language area. And I don't know where the technology came from. I know Elon Musk has got, I think, is it called Neurolink, that he's working on? That's kind of where your question is heading. And so these, wherever she was and whatever the technology was, they implanted something, and she was able to get to the point where she could have full-on conversations with her husband again. And so I firmly believe that just like we can put in artificial knees and artificial hips and new eyeballs, and there will be more and more that we can do to help people that have deficits in some way in the brain. Maybe with epilepsy, epilepsy is kind of a thing where these little spots in the brain kind of start firing off when they're not supposed to, and then they cascade. And maybe there's a way to put something in there to keep an eye out for some of these cascades and kind of do something to fight back against it. And I mean, we already have automatic internal defibrillators for hearts for people that have arrhythmias. They can implant a device that's constantly watching the heart, and when it sees an arrhythmia kick in for a certain amount of time, it'll just give them the shock right there in their chest. And so, yeah, I think completely we're going to keep heading in that direction. And that's, there's always obviously ethical questions there that happen over time as you get more and more into that. But just the science itself and the engineering, I think definitely there's lots of abilities to keep growing in that area. Yeah, great question.
I've got one more question kind of relating to the ethics. So I've heard of the specific problem had to do with autonomous driving, where you would actually have to teach it through certain models, like in certain situations, who would it have to kill? Like if the car is heading towards,
right,
like a family and then like a dog and a kid, like it
right.
needs to decide, right, who is going to hit. And my guess is that most people, if they flipped on the news and in one case they saw that just a drunk driver hit a family, In another case, they saw that autonomous driving decided to hit the family. Most people today would be more upset from the AI, I think, at least. Like they would be like, oh, who was the programmer or whatever that made that decision?
Mhm.
Do you think the shift towards trusting artificial intelligence is just a matter of time, or is there a matter of time and the next generation will trust it more? Or do you think there's like a technological piece missing that will make the shift where we'll trust autonomous driving more, we'll trust AI doctors and surgeons more, things like that?
Mhm. Yeah, no, that's a really interesting question. I think my own personal opinion is I would rather have some really smart autonomous vehicles out there driving around and driving everybody around, making the best decisions they can make. If assuming they're, I don't know if we're there yet. It sounds like we're pretty close with all that. But I think, from experience of watching a new generation, each time a new generation comes in, they get used to. I think that was a great way to frame the question because I mean, the younger generation, I'll date myself. Whatever it was, 30 years ago, somebody said, there's going to be this thing called a cell phone, which will be able to follow you around with your phone number. And I was like, there's no way that'll work, and people will be texting all the time. And then they showed people, I guess it started really hitting big in Europe, texting before it kind of hit the US. And I remember thinking, well, that's stupid. But it's the younger generation typically that takes on new technology and says, come on, let's go with it, and understand that there are going to be problems, but there's no looking back. I mean, I heard the story about Henry Ford. His dad was from the horse and buggy era, and Henry Ford had to tell him, look, this is where the future is. He was the young guy in that scenario, and he brought the cars in, and I'm sure there was a lot of people. I mean, you can argue whether we're better off because of cars. I mean, there's a lot to be said about the rural lifestyle that we gave up, 150 years ago or whatever it was. But again, it's the new generation is the one that takes on new technology and embraces it. So I think that's probably how it's going to happen because I mean, your scenario was perfectly stated. Okay, it's like, are you going to get more mad at this drunk driver or this car who consciously, in its own way, made a very tough decision and had to do what it had to do? So it's a interesting idea. There's a great book. I don't know if he's as popular now as he was back when I was reading him, but Isaac Asimov, have any of you ever read his work? He was a very prolific writer, really a polymath, very interesting guy. And he wrote the Foundation series is really interesting. And then the one that I was going to talk about is iRobot, is a series of books. And I actually was going to put it in the presentation, but decided to leave it out because felt like it was getting too long. But he wrote the 3 rules of, I forget what it's called. I guess the 3 rules of robots. I'm not quite sure, but they were like, a robot cannot do any danger to human unless the human is in danger themselves. So there are these 3 laws, and what he found was these laws can have weird conflicts that you would not even imagine when you frame really simple laws like that. So I think that'll be interesting to see how these sort of law. I mean, that's what these are that you're talking about. The autonomous vehicles using its own internal laws or rules to decide what to do. And yeah, what if it's going to go off a cliff and hit a bunch of people below, or it's not sure what's below? There's a lot of uncertainty that can happen there. But anyway, I highly recommend those books. They're extremely readable and well written and fascinating. He was a science guy too, so he came from his science fiction from a science background. So he thought things through well and had lots of twists and turns in his stories, and won a lot of awards for his writing. So I highly recommend his stuff. And actually, I haven't read it in years. I'm gonna have to go back and read it now.
Chris, I have another question. You talked about heuristics like very briefly, and I also have like a very brief understanding, but just for context, Paul Council talks about it a lot in terms of business. And he says, if you want to be really good at copywriting sales, study heuristics. I believe his context was that most people think humans are these rational, logical beings, and yet, like, vast majority of our behaviors are emotionally driven. And I
Yep.
believe he said like heuristics are like mental shortcuts in the brain that trigger emotions. So, for example, if I say something like someone's died, everyone starts feeling sad. Or if you give something, he uses this one. If you give someone coffee when they walk in, they have this indebtedness feeling, and now they're going to be more willing to give you something and maybe buy from you. So I guess in your marketing agency context as well, like, what's your understanding of heuristics, and like how can that be applied in the business sense as well?
Yeah, again, I always think of heuristics as rules of thumb. I've never heard it framed like you did, but that's an interesting way to think about it, is it's sparking an emotion. I just think of it as things that seem like sort of common sense, and maybe you can't always articulate it. It's almost like another book I really like is called Blink. I don't know if you've ever heard of the book. It's by it's one of the guys that darn, I'll think of it in a second, or maybe one of you can look it up. But it's the idea that if you're working in a domain long enough, you just start being able to recognize something in a blink, because you've got enough data, and you may not even be able to articulate it completely. You might have a little bit of a heuristic, like I have a feeling that this is what I'm doing, but really what's behind it is a lot of pattern matching that you've done through just tons of input in whatever domain you're working in. And so that's one thing there. The other one is what you said too, is our decision making, as logical as we like to think we are, is driven so much by emotion and feelings. And then we often go back and put logical thinking on top of it just so we can have an explanation for why we did what we did, even though that really isn't the explanation. It's kind of sounds good on paper. So that I'll have to look up heuristic again, because I would like to see if there's more to it than that. But I
I
get
think
the
it makes
feeling
sense. So it's like you're talking about, it's basically pattern matching. So in his
Mhm.
sense, it's like maybe through evolution, to evolve or to survive, you develop these patterns, and then you can just trigger that because for even the indebtedness thing, like you're more likely to survive if you give to someone who gives to you. So
Mhm.
that's just how your brain works, how the network. Yeah.
Yeah, I mean, I think that is a good heuristic. It's almost like a guiding principle. I mean, I feel that from the uncommon folks. I mean, in the network, I feel like everybody has that sort of feeling of, to one degree or another, of I want to give back because I will get back, but but I also want to do it because it feels good to do it, And so it's kind of a combination of self-interest, but also, self-interest in the long term and short term, really. I guess it's self-interest in both cases, because in the short term, you're getting a good feeling by helping somebody. In the long term, that might come back to you. And I think Alan mentioned this too. It develops trust. I mean, trust is the real currency that makes things work. And we're developing these relationships, through calls, or if we're in business, we're developing relationships that hopefully will lead to trust, that I bring value to you and I'm not going to lie and cheat you. I mean, that's the real basis of a trusting situation. So I think there's a lot to be said for the self-interest of helping other people.
Awesome. Does anybody else have any questions? Cool. Well, Chris, I know it. Yeah, you were a little hesitant to share originally, but I had a feeling you were gonna have some vast knowledge. So I'm really glad that you took the opportunity, and hopefully you can catch up on some sleep this weekend.
Well, I was cussing you out a couple of times in my head the last couple of nights, but I'm glad you pushed me. And I got to tell you, your soft touch kind of pushed me over the edge, because you didn't hard sell me on it. It was a very soft sell, but I'm glad I did it, because I had a lot of fun putting it together. I learned a lot. I mean, or relearned some of the things too, and it, like I said, it re-sparked my interest in all of this field. And so I really feel like diving in even more, not just because of our business and tools that we need, but just staying on top of the current research and being involved with all of you all who are also have an interest in all of this area. So yeah, thanks for prodding me and kind of giving me the little push to get through it, because I'm glad I did it. So thanks, Max.
Yeah, of course. There we go. Next call will be tomorrow morning if everybody wants to hop on, and have a good night.
Sounds good. Thanks, everybody.